Just so you have an idea of how this oxidative cleavage happens, it actually starts with an alkene addition reaction. So we have the ozone and the alkene, and in this first step, the alkene attacks this oxygen, and that's acceptable because that can push a pair of electrons over to this positively charged oxygen. And then at the same time, a lone pair from this negatively charged oxygen attacks one of the carbons of the double bond. When you do this, we get the ozone added across the alkene. We get this structure, which is called a mol ozonide. All right, to help us kind of keep track of this, I'm going to highlight two portions of the molecule, and we'll see what happens from here. So this molozonide doesn't last very long. It breaks apart, and the way it does this involves a lone pair on one of the oxygens, and that lone pair comes down to form a double bond, pushes those electrons up here to form another CO double bond, and then that pushes those electrons to this oxygen as a negative charge. So if we track what's going on here, we end up with an O minus, an O plus. This is our red portion, and our green portion, and I'm actually going to draw it upside down, and you'll see why in a second. We have that double bond O. So that's the green portion. So then, once those break apart, they actually rejoin, but this one joins upside down of where it started, if that makes sense. So this will add, I'm going to use the double bond of this oxygen, that comes over to here, pushes that up onto the positive oxygen, and then this negative charge adds there. So this all happens in one step, and then the product we get from this looks like that. And let me go ahead and highlight our red portion again and our green portion, just like that. And this species is called an ozonide. So this is as far as we get with the ozone. And then we add either the oxidizing agent or reducing agent. We'll look at the reducing agent, the DMS. So we add the DMS to this. And this part's a little bit unusual as well. The lone pair on DMS will come over and attack this oxygen, push those electrons down to form the double bond O. These electrons come here to form the double bond O, and then this bond leaves the carbon and comes back to the sulfur. So there's a lot going on there, but the sulfur ends up forming a double bond to this oxygen. And that gives us a species known as DMSO dimethyl sulfoxide. But then the two carbonyls that break off of this, we have the one that was highlighted in red, becomes a double bond O, plus we have the one that was highlighted in green that becomes a double bond O. And that's our products. So this is not a mechanism that you're going to be required to know for Chem 233, but I did want to walk you through the steps so you can actually see how this alkene gets cleaved.